There we go.
All right. Question or homework?
For number 44,
Number 44, okay.
in part B, where they ask for the power of the first resistor,
Okay.
where do they get the current from, the 0.06?
I'd have to work it. All right, so we have. The way I'm gonna remember, so let's actually bring it up. So 44, we've got resistor, power supply, resistor, power supply, resistor. All right. So this is 6 volts. This is 12 volts. R1 is 15 ohms, so that's 15 ohms. R2, 30 ohms. R3, 45 ohms. And R4, 60 ohms. Oh, wait, your question was on 44? About the power?
Yeah.
Presumably in the previous question. Did you have a problem with 43?
No, because they said that the current of the first resistor was 0.179, but then in part B they put 0.06.
I figured that had to be a mistake, but I was wondering the same thing.
This is chapter 20, of course, I don't have that there. It should just be the currents that were in the previous problem. Well, let's just run through it. Let's do mesh analysis. So I'm just going to arbitrarily pick current A and current B. My two unknowns, so my voltage loops. I have, let's start here and work our way counterclockwise. So I have 6. Come across here, I'm going against current for A, so plus 15A. Going with the current for B, minus 15B. Plus 60A equals 0. And then the other loop, I'll just start here and work my way in the same direction as the B. So that's 12 minus 45B minus 15B plus 15A minus 30B equals 0. So taking the 6 over, I've got 75A minus 15B equals negative 6. And here, just got the 12. So A, I have 15A minus 75, 90B equals negative 12. So we'd have made a careless error. For A's in the top one, this is 5 times that. So I'm just going to multiply this bottom equation by negative 5. So I have 75A minus 15B equals negative 6. And then negative 75A plus 450B equals negative 60. And so I have 435B equals negative 66, so B would be negative 66 over 435. Which is something. Hopefully, what are the answers they have? 66, 435 divided by. So I'm getting negative 0.1517 amperes. A, just plug into this one, so 15A equals negative 12 plus 90B.
Wasn't that, the negative 60 supposed to go to positive 60? When you multiply by negative 5 with 12?
You are correct.
Don't you normally have a third current in the middle?
In mesh analysis, you do one current per loop, and the current in the middle is going to be a combination of A and D. So, so 54 divided by 435, like 124.
That's the same thing I got.
Okay.
B.
And so this changes to 0.124. See, did I get it? So I add that stays negative 12. And so 90 times that, and 12 minus, and I'm getting, that is negative 0.8276, and then divide by 12. Negative negative 0.06897 amperes. You got a different answer? That would be the current that's flowing across the 60 ohm resistor, and the other one is the one flowing across the 30 and the 45 ohm resistors. And then in the middle, assuming that there's not another careless error,
I got 0.05517.
0.05517. All right, so if I plug into the first equation, let's see what I get there. So B 0.124 times 15. All right, so it did something wrong here. 124 becomes minus. Oh, I'm not quite sure what I did before. Somewhere around 0.055 or 0.056. Okay. Obviously, there's some rounding issues in there. So in the middle, the current in the middle, I know that I have A going down. The way I have to find A is going down and B is going up in the middle. A is negative 0.055, which means it's going the other direction. So I have 0.0555 going up from A, and then B is 0.124. And so since they're now in the same direction, just add them. 0.1795-ish amperes. So those should be the currents that they are using across each of them. So this is, I had A going that way, but it's negative, so going this way, 0.0555 amperes. B, 0.124 amperes. This one, 0.124 amperes. That, 0.1795. All right, so with Carol's errors out of the way. Does this match the answers? Okay, but in the power problem, they use different current? Okay, I would say that is a typo. So it sounds like that would resolve your issue, Sarah?
Yeah.
Okay. Other questions?
I think in the homework they subtracted the current going through resistor 2 by the current going through resistor 4.
To get the current going across resistor 1?
Yeah.
Yeah, that should not be. So many places to make a careless error.
I also had a question on the last problem.
88, was it? No, 80,
Yeah.
problem 80. Yes?
So when they were finding the equivalent resistance, did they just ignore the 2R in the middle?
Yeah, they did. The justification for that, alright, so you've got point P over here, it cruises along, you've got 2 ohms here, you've got a junction, 2 ohms there. Oh, no, sorry, not 2 ohms, 2R, whatever that is. So 2R, 2R, this is 2R also. R. Little r, and then same thing over here. So the potential difference between P and Q should be the same regardless of the path that we take. So if I'm cruising along here and along this path, that should be the same potential difference as going straight or going down that route. Same 2 points should have the same potential difference. Their argument is because of symmetry that whatever current is flowing across here also has to be the same current flowing across there. Well, back up for a second here. The argument is because of symmetry that the voltage at this point right here must be, or the potential difference between P and this spot must be the same as between this spot and Q. That there's no reason why I would lose a different amount of potential at this point than this. I would assume that whatever potential I lose here, I'm gonna lose here also. If I lose the same potential here and here, well, I know then the current flowing across here is whatever potential that is divided by R, divided by 2R. And the potential lost here would be delta V over 2R. And since I have the same current flowing this way into the junction as I do in this upper path this way, there can't be any current flowing down this path. Same argument over here, there can't be any current flowing across that side. And so that's why they just ignored it.
That makes sense.
Yeah. If it had not have been, if we'd not had the symmetry, then it would have been a more complex problem. Other questions? On either of these or a different one? All right. So the quiz is a little bit different than the homework problems. I mean, if you know how to solve this problem, you should be able to handle the quiz. It's one that is a lot closer to how it looks on the test, other than batteries might flip and the numbers will change. So just be warned. I should have mentioned it ahead of time, but I didn't, because I'm me. So what will happen is you'll take the quiz, and let's say you do, for some reason, you do badly on it. You're gonna get something very, very similar to it, different numbers, different orientations, something very similar to it on the test. If you get it on the test, I'll go back and replace the quiz grade. And I don't need to record my erasing the board.